In this video, we are going to see inverse Laplace transform, but with the given condition for RoC. Mostly these numericals are asked in the exams. So let us start with the solution for this example. So for this example, x of s is given as minus s minus 4 divided by s square plus 3s plus 2. Now again apply the rule for partial fraction expansion. Check out the degree of numerator and polynomial. So here in this case, degree of numerator is less than the degree of denominator. Hence go for partial fraction expansion. So to find out partial fraction expansion, we must find out the roots of denominator polynomial. So x of s is minus s minus 4 divided by first term as it is. Split the second term 3s into two parts where addition will be 3 and multiplication will be 2. So we can represent it as 2s plus s, which will be 3, and 2 ones are 2 will be the third term. So take common. So make pair of these terms, first term and second term. So in this case, in the first term we have taken s common, so remaining term is s plus 2, plus in the second term we can take 1 common and the remaining term is s plus 2. Now minus s minus 4 divided by, so from the terms we can take s plus 2 common and the remaining term will be s plus 1. So now once we get the roots of polynomial, apply partial fraction expansion. So we get x of s as minus s minus 4 divided by s plus 2 s plus 1 is equal to, here we have two roots, so two coefficients, e upon s plus 2 plus b upon s plus 1. So again simplify these terms, minus s minus 4 upon s plus 2 s plus 1. So take cross multiplication on the right hand side, so a into s plus 1 plus b into s plus 2 divided by s plus 2 into s plus 1. So here the denominator terms are same, so we can cancel it. The remaining terms are minus s minus 4 is equal to a into s plus 1 plus b into s plus 2. Now we are supposed to find out a and b, so use the same logic to find a, put b equal to, so we have to make b term 0. So for the bracket related with b is s plus 2. To make it 0, we have to substitute the value of s. So to find out a, s should be equal to minus 2. So we get the answer as minus of minus 2 minus 4 equal to a into minus 2 plus 1 plus b into minus 2 plus 2 becomes 0. So here it is plus 2 minus 4, so answer is minus 2 equal to, so a into minus 2 plus 1 is minus a, so we get the value of a as 2. Similarly, go for the second term. To find b, put, to find b we have to make a 0, so the bracket of a is s plus 1, so put s equal to minus 1. So we have minus of minus 1 minus 4 equal to a into minus 1 plus 1 becomes 0 plus b into minus 1 plus 2. So minus 3 is equal to b. So we get b equal to minus 3. So put these values in the equation where we have used the partial fraction. So to get x of s, so we have x of s as a upon s plus 2 plus b upon s plus 1. So the term where we have taken the partial fraction expansion. So our a is 2, so 2 upon s plus 2. Now b is minus 3, so minus 3 upon s plus 1. This is our x of s. Now we are supposed to find out the inverse Laplace transform, but in this particular numerical the conditions are given. If it was simple numerical, straight away we would have applied the standard results and straight away we can go for the answers. But in this case we need to find out the first condition, which is that RoC is less than minus 2. So for the first condition we have the RoC, that is real part of s, should be less than minus 2. Now we have x of s in this way, 2 upon s plus 2 minus 3 upon s plus 1. Now in such cases you must use the standard results very carefully. We have the combination of 1 upon s plus a minus 1 upon s plus a, 1 upon s minus a, minus of 1 upon s minus a, in that way. So those 4 results should be taken into consideration, and then by looking at RoC, select the appropriate equation. So for in this case we need to make use of a standard result where we should get RoC less than minus 2. RoC is less than minus 2. So we cannot use the first result, that is e raised to minus at into u of t. For that case RoC is greater than minus 2. But here the needed or the required equation is less than. So whenever it is less than, most of the times you have to use the result of u of minus t. So for this particular numerical we have to use standard results e raised to minus at u of minus t. For this we have the Laplace transform as one upon s plus a for RoC sigma less than minus a. So for both the terms 2 upon s plus 2 and 3 upon s plus 1, we have to use the same result so that we get RoC less than some constant value. So by taking inverse on both sides, so we have x of s becomes x of t equal to 2 is the coefficient, so it will be as it is. 1 upon s plus 2 will become, its inverse will be e raised to minus 2t u of minus t with RoC sigma less than minus 2, and the second term minus 3 will be as it is, e raised to minus t u of minus t with RoC sigma less than minus 1. So if you look at the common region between these two, sigma less than minus 2, sigma less than minus 1. So common region will be sigma less than minus 2, which is our required RoC. So we have obtained the inverse for the first condition. Now the second condition given is RoC should be greater than minus 1. So let us go for the second condition. Real part of s should be greater than minus 1. So again take the equation of partial fraction expansion and now check what standard results we can use where we get RoC as greater than something. So remember always, whenever it is greater than, so you have to use the standard results of the equation where you get u of t in the answer. Okay, So we have e raised to minus at u of t with Laplace transform 1 upon s plus a with RoC sigma greater than minus a. So take inverse Laplace transform on both sides. So we get x of t equal to 2 as it is, 1 upon s plus 2 will be e raised to minus 2t u of t with RoC sigma greater than minus 2, and the second term minus 3 upon, it is s plus 1, so its inverse will become 3 into e raised to minus t u of t with RoC sigma greater than minus 1. So if you look at the common region between these two, RoC is sigma greater than minus 1. And now for the third condition, we have the RoC as between minus 2 and minus 1. So here in this case, we want RoC between these two. So see, again rewrite the answer of partial fraction expansion: 2 upon s plus 2 minus 3 upon s plus 1. Now in this case, we need RoC, first RoC as the real part of s, that is sigma is greater than minus 2 but less than minus 1. So for first part it is sigma greater than minus 2. So if it is greater than, you have to use standard equation for u of t. So in this case, the first result or first identity for the first RoC, we have to use, we have e raised to minus at u of t, its Laplace transform is 1 upon s plus a with sigma greater than minus a. So for this first part we get RoC greater than minus 2, so we have to use this result. And for the second part we need RoC should be less than minus 1. So whenever it is less than, the equation should be of u of minus t. So for the second term, we have to use the equation as e raised to minus at u of minus t will have Laplace transform of 1 upon s plus a with RoC sigma less than minus a. So make use of these two equations in the above part and take the inverse. So taking inverse on both sides, so inverse of x of s is x of t. So in the first case we have 1 upon s plus 2 in the equation, and here RoC should be greater than minus 2, so we have to make use of the first equation. So x of t equal to 2 will be as it is. So inverse of e raised to inverse of 1 upon s plus 2 will be e raised to minus 2t u of t with RoC sigma greater than minus 2. And for the second term, we have to make use of the second equation. So e raised to minus t u of minus t with RoC sigma less than minus 1. So here if you look at the RoC, here we have sigma less than minus 1 and greater than minus 2. So common region between these two will be minus 2 sigma minus 1. So RoC is between minus 2 and minus 1. So in this way we can obtain the inverse Laplace with different conditions for RoC. Remember, here you have to solve it using normal method, use partial fraction expansion, find out the coefficients, and whenever you are taking the inverse, at that point of time check and select the standard results in such a way that it meets the conditions for RoC. So this is the example of inverse Laplace with the given conditions of RoC.